So here we're going to begin to look at solving equations and solving, first off, one-step equations. So let's talk about what an equation is. And first of all, we need to understand that an equation is when we have an equal sign. Second, we need to know what it means to solve. And to solve would be to find the unknown value for the variable or for our letter. So we're just going to walk through some examples here. The reason we call these one-step equations is because there's one step to do. There's one operation. So I do want to stress that every time I solve any equation, the first step is going to be draw a line down that equal sign. And so now we also want to be thinking about what our inverse operations are. So we can think of the opposite or the inverse of tall would be short. The inverse or opposite of right would be left. And so the inverse or opposite of adding is subtracting. So here we look at x plus 3, and to get the 3 to the other side, to get x all by itself, we subtract 3 from both sides. Whatever we do to one side, we have to do to the other to keep the equation balanced. And so here we just have x equals, and 2 take away 3 is a negative 1. So this is an example of how we undo our addition and how we solve for x. Now I want to talk about how can I check to see if that answer is correct. So we can check our work. And we could do this on every single problem to see if we did the problem correctly. And so how do we do that? Well, we first start by writing the original problem. X plus 3 equals 2. That is the original problem. The next thing we're going to do is we're actually going to substitute. We are going to plug in the answer that we got. We got x equals negative 1. So we are going to plug in a negative 1 where the x value is. And we are simply going to take care of our addition here. On the left side, negative 1 plus 3 is 2. And on the right side, it is 2. And so we ask ourselves, is that a true statement? Does 2 equal 2? Well, yes. So check, it works. Meaning, if it works, it means you got the correct answer. So again, each of these we could go back in and check our answers. Let's go ahead and look at example 2. Example 2 here, we're going to have a negative 7 equals b minus 3. And I cannot stress enough, draw the line down the equal sign. It should be your first step. It should be a habit that you do every single time you're solving an equation. Here our unknown value is b. I'm also going to suggest every single time I want us to change subtraction to addition. Add the opposite. And so to get b all by itself, what kind of 3 do we have? We have a negative 3. So since we have a negative 3, the opposite of a negative 3 would be to add 3. Whatever we do to one side of our equation, we do to the other. I hope you notice that I line everything up. I'm adding 3 on the right, and I put it right below the negative 3. I'm adding 3 on the left-hand side of my equal sign, and I lined it up with its like term, the negative 7. And so I go ahead and this cancels because we know opposites equal 0. I bring down my b, and a negative 7 plus 3 is a negative 4. And if we check our answer on this one, Again, I would like for you to start off by writing the original problem, even with the subtraction sign. We are going to plug in for B the answer that we got. And if we did our math, -4 minus 3, you can type it in on the calculator, is -7. And so check, it works. So again, you can check every single one of your problems and you can check and see if they work. Carter, can you please get the dog? Sorry, excuse me. Let's go ahead and look at example 3. So on example 3, we have a -4x equals 6.4. Now, what does it mean when we have a -4 next to the letter x? We need to think about what that operation is. And it doesn't hurt to put the dot there. It means multiplication. So that says -4 times x. So the inverse of multiply is we want to divide to get that x all by itself. So we're going to divide both sides, and we want to divide it by a -4. The reason is because anything divided by itself is 1. So a -4 divided by a -4 cancels out to be 1x. And that's what we want. We want to divide by the -4 because we want it to be a positive 1x. And when we do our math here, we get a -1 6/10. So the inverse operation on this one, the inverse of multiply, was to divide both sides. Let's look at example 4. I have 5 examples, so we're getting close. On example 4, we have 19 equals r, and it's a fraction, divided by 3. But remember, a fraction means division. The fraction means division. And again, right away, I'm getting that line drawn down the equal sign. I want to isolate my letter R. I want to get my letter R all by itself. So because this fraction means divide, the inverse of divide is multiply. And we can multiply both sides. We want the R by itself, so we want to multiply by the 3. And what that does is 3 divided by 3 here, you can think of that multiplication as a big old fraction bar, is going to give me 1r. And 3 times 19 is 57. So we did the inverse of that fraction, and a fraction means divide, and that inverse is to multiply both sides, so that we get our r by itself. Last example. Not sure if we've heard of this yet, but the reciprocal of a number. So if I had 2/3, the reciprocal of 2/3 is 3/2. And what I want you to see about reciprocal, if I had 2/5, the reciprocal would be 5/2. And what's nice about the reciprocal is that if we multiply our reciprocals, if we multiply our original fraction by the reciprocal, we actually get, I'm trying to find the eraser here real quick so I can get rid of my commas. If we multiply a fraction by its reciprocal, we actually get a number 1. 6 divided by 6 is 1. Anything divided by itself is 1. So if I look at the next example, 2 times 5, I get 10 over 10, and that equals 1 whole. So reciprocal is going to be important in example 5. 5 is 4/5 times x equals 16. Make sure that line gets drawn. And because we have a fraction next to our variable, our goal is to get the x by itself and make it 1. And so this is where it would be a good time if we multiplied by the reciprocal so that x is 1. So if I multiply, and remember, whatever we do to one side of our equation, we need to do to the other. So here on the left-hand side by the letter x, I can prove it to you. 5 times 4 is 20, over 4 times 5 is 20, and we know that 20 divided by 20 is just 1x. Do we have to write the 1? No, but we can. They mean the same thing. X by itself means a 1x. And again, how we multiply fractions is we just multiply straight across. How do I turn 16 into a fraction? Well, you can place any whole number over 1. And so we multiply straight across here, and 16 times 5 is 80. And 1 times 4 is 4. And if we ask ourselves, how many times does 4 go into 80? Or if we can simplify this, we get the answer 20. So this is an example of where having the reciprocal or multiplying both sides by the reciprocal to get x as 1 helps you to simplify and solve this problem. That's it on solving one-step equations.